So if you've followed me and you've watched a couple of my previous videos, you should now be happy with how to integrate a constant over a linear expression and a linear expression over a linear expression. Today, we're going to look at integrating a quadratic divided by a linear. So integrating something like this. Now, yesterday, we talked about the fact that if the order on the top is equal to or bigger than the order on the bottom, you have to use long division first. Now, what is the order at the top here? So it's a quadratic, so it's order 2. So that's an order 2 polynomial, that's an order 1 polynomial. So again, like yesterday's video, we have to use long division first. Step 1, long division. So let's do a real example of this. So 2x squared take away x plus 1 over 3x minus 1. Let's do the bus stop method. So numerator inside the bus stop, divisor on the outside. So we start by doing 2x squared divided by 3x. That's going to give us 2x over 3. So we got here 2x over 3. And then we want to do 2x over 3 multiplied by our divisor and write it underneath. So that's going to give us 2x squared again, doing that times the 3x. And then 2x over 3 times by minus 1 is going to be minus 2/3 of x. And we're going to subtract this entire second row from the first row. So now when we do this, this here is going to become 0, the quadratic term. Now we've got minus x minus minus 2/3 x. So minus x plus 2/3, that is going to be minus 1/3. So minus 1/3 x there. And we still got the plus 1 here. So now we need to go again. So we're going to do minus 1/3 x divided by 3x. So if we do that, we should get minus 1/9. Okay, so minus 1 over 9 there. Sorry, I didn't mean to put two minus signs there. Let me just make that into one minus sign. There we go. So now we're going to do minus 1/9 times 3x minus 1. So again, write the result underneath. So we should get, if we do that, minus 1/3 x again. And then minus 9 times by minus 1 is positive 1/9. And again, we subtract the second row from the first row. So if we do that again, we're going to get no x terms, just 0 there. And then 1 minus 1/9 is going to be 8/9. Okay, so 8 over 9 there. So our quotient is 2x over 3 take away 1/9, and our remainder is 8 over 9. So 2x squared take away x plus 1 divided by 3x minus 1 is going to be equal to our quotient, which is the result we get when we divide. So 2 over 3x take away 1 over 9. And then plus the remainder over the divisor. Remainder is 8 over 9. So add on our remainder. That's the remainder divided by the divisor. So 3x minus 1. And this is all with respect to x, like that. So again, we got 2 over 3x there. We got minus 1/9 there. I'm just going to tidy this up a bit. So we got 8 over 9 on the numerator there. I'm going to bring the 9 to the bottom. So what I mean by that is keep the 8 on top and then just put the 9 down here. So 9 times 3x minus 1. This is all with respect to x. I'm just going to also expand the brackets as well here just to make this look neater. So we've got 27x minus 9 on the bottom there. So now we're integrating this. So using year 1 methods, we should know how to integrate 2 over 3x. That is going to give us 2 over 3 x to the power of 2 divided by 2. Integrating minus 1/9, that's going to be 1/9 of x. And then integrating this, if you watched video 1 of integrating algebraic fractions, you should know how to do this, okay? So this is going to be 8, and then ln modulus sines 27x minus 9. Do the derivative of this linear expression, that's 27. So you divide by 27, and then plus c, because we have no limits with this question. Let's just tidy everything up. I tried to tidy this term up there, but I made an error with the numbers. So 2 over 3 divided by 2, that should be 2 over 6, which is 1/3. I wrote 1/6 here for some reason. So 1 over 3 x squared, and then minus 1/9 of x, and then plus this 8 over 27 ln 27x minus 9 plus c. So now we're happy with integrating a constant over a linear, linear over linear, and quadratic over linear. Now, if the powers get big on the numerator, so if we go to cubic, quartic, so on and so on, it is exactly the same method as here, long division. So remember, if the order is equal to the order on the bottom or bigger, so like all of these here, so everything going up from there, then you're going to do long division first. But if it's like video 1, like what we did in video 1, then obviously now you know how to do that using ln's, okay? So if you do have any questions on that, let me know. Now in tomorrow's video, we're going to look at integrating a constant over a quadratic. So we've dealt with linears on the bottom, but what if the bottom was quadratic? Stay tuned, follow me and watch tomorrow's video because we're going to go through that.